Here is a problem based on a car accelerating and decelerating. A car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta and comes to rest. Total elapsed time is t, then the maximum velocity acquired by the particle is. Okay. Now, if you look at this, there are two parts as far as the journey is concerned. What are the two parts? In the first part, the car starts from rest, accelerates for some time t1 and at what rate alpha, and then it starts decelerating and it decelerates for time t2, finally coming to rest. Now, the question is, what is the maximum speed? Maximum velocity or maximum speed. Now, the speed becomes maximum at the end of the first journey or at the beginning of the second journey. So, let us do this one. Now, if I consider the first part of the journey, I will write V max as the final velocity for the first part of the journey. V max is equal to u plus at alpha t1. And for the second part of the journey, I will write V is equal to u plus at, that is t2, final velocity is 0, initial velocity is V max, it decelerates at beta into t2. So, I will write V max also as beta into t2. So, now we can simplify this equation. This is equation 1 and this is equation 2. We also know that t is equal to t1 plus t2, t is equal to t1 plus t2, isn't it? So, now let us simplify this one. How do we simplify? So, notice that from 1 and 2, what do we have? We have V max is equal to alpha t1. So, alpha t1 is equal to beta t2. So, I have t1 by t2 is equal to beta by alpha. So, now we can eliminate from equation 1 and 2 and we can get V max square is equal to V max is equal to alpha beta divided by alpha plus beta into t, alpha beta by alpha plus beta into t.